Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how to use conversion factors to solve problems. So let's get into this. So the first problem is a typical non-obese male has about 11 kilograms of fat. Each gram of fat can provide 38 kilojoules of energy. If this person requires 4.8 times 10 to the 3 kilojoules of energy per day to survive, how many days could he survive on his fat alone? So the first thing you want to do for these type of problems is pull out the information. First thing you want to do is break this up into two parts. The first part is going to be, let's pull out the conversion factors. Anything that has a relationship to something else in the problem, that's going to be a conversion factor. So it says that a typical non-obese male has about 11 kilograms of fat. That's not related to anything, so we'll come back to that. Each gram of fat can provide 38 kilojoules of energy. So 1 gram of fat is equal to or related to 38 kilojoules of energy. So gram of fat and 38 kilojoules of energy are related to each other. We can use that as a conversion factor. So that's really the only conversion factor I see. It says if this person requires 4.8 times 10 to the 3 kilojoules of energy, right, per day, right? So here, that's a relationship. So here we have kilojoules of energy related to 1 day, right? So that's a relationship that we can use as a conversion factor. And so we pull out the conversion factors. So then the second part is to figure out where we're going to begin and where to end in the problem. So that's where the question is going to come in. So 99% of the time, the end and the beginning are in your question. So here, where's the question? There's the question. The beginning of the question is the end of your problem. How many days is the beginning of the question? So we want to know the number of days. So we want number of days. That's what we need to find. Where are we going to begin? Well, how many days could he survive on his fat alone? Well, what's the fat? 11 kilograms up here. So 11 kilograms of fat is what we're going to begin with. So we're going to start with 11 kilograms of fat on the top, and we're going to then start using our conversion factors. So kilograms of fat. Well, we know that 1 gram of fat is related to 38 kilojoules of energy. So if we convert this to grams, we can then use that conversion factor. So I know that 1 kilogram is equal to 1,000 grams. So I'm going to put 1 kilogram of fat on the bottom, and then 10 to the third, or 1,000 grams of fat on top. So kilograms cancels out. Now I have grams of fat. So now I can use the 1 gram of fat is equal to 38 kilojoules of energy. So we could set up that conversion factor. And so since I have grams of fat on top, I'm going to put 1 gram of fat on the bottom, and then 38 kilojoules of energy on top. So now the grams of fat cancel out. Now I have kilojoules of energy. I need to get to days. And it looks like we have a relationship between kilojoules of energy used per 1 day. So now I can use that to convert to days. So now I'm going to put kilojoules on the bottom to cancel out. So this is 4.8, 8 times 10 to the third kilojoules, and then 1 day on top. So kilojoules cancels out. I have days on top. I am done. Now all I need to do is calculate. So I have days. So I'm going to multiply across top, divide by the bottom, and I'll get my answer in days. And when I do that, I get 87 days. 87 days. And remember, the number of sig figs for your answer, if you're multiplying and dividing, the rule is that your answer should have the same number of sig figs as the least number of sig figs in your measurements. So we have 2 sig figs in 11. This is an exact relationship, so we can ignore that. Here we have 2 sig figs in 38, and here we have 2 sig figs in this number here. So that's going to be 2 sig figs. So our answer has 2 sig figs, or should have 2 sig figs. And it does. 87 has 2 sig figs. Okay, number 2. The kidneys of a normal adult female filter 115 milliliters of blood per minute. So again, we're going to pull out the conversion factors first. So this 115 milliliters of blood per minute, that's a relationship between blood, milliliters, and minutes. So that's a conversion factor that we can use. So we're going to underline that. If this person has 5.168 quarts of blood, how many minutes will it take to filter all of her blood just once? Well, we don't have any more relationships, so now we have to figure out, well, where do we begin and where do we end? And that's where we're going to go to the question for. The beginning of the question is the end of the problem. So how many minutes? So that's the beginning of the question. That is the end of our problem. We need to get to minutes of time. Now, where do we begin? Keep reading the question. How many minutes will it take to filter all of her blood once? Well, what's the amount of blood she has? 5.168 quarts. So that's where we need to begin. This is a standalone information. It's not related to anything. So we're going to begin with that. So now we're going to start with 5.168 quarts over 1. And now we need to convert quarts to something. If we could get it to milliliters, then we could then use milliliters to convert to minutes. So we need a relationship between quarts and milliliters, or maybe liters. So if we look at quarts and liters, or maybe we could go to quarts and gallons, however you do it is up to you. But what we're going to do is we're going to use gallons and then liters. So I know that there are 4 quarts in a gallon. So I'm going to put 4 quarts on the bottom, 1 gallon on top. So quarts are going to cancel out. And then I know that 1 gallon is equal to 3.785 liters. Let me just double check that. 3.785 liters, yeah. So 1 gallon on the bottom and 3.785 liters on the top. So gallons are going to cancel out. Now I have liters. Now I can convert that to milliliters because I know 1 milliliter is 1/1000th of a liter, because milli is 1/1000th, right? Or I could say 1 liter is equal to 1,000 milliliters. Either way works. So I'm going to put 10 to the negative 3 liters on the bottom because that's a 1/1000th of a liter, and 1 milliliter on top. So liters cancels out. Now I have milliliters. Now I can use the 150 milliliters per blood per minute. So now I can convert to minutes. I have milliliters on the top. I want to put that on the bottom. So I'm going to put 115 milliliters on the bottom to cancel out, and 1 minute on top. So milliliters cancels out. But what do they want? They want to know How many minutes? Well, we just got minutes on top, so we're done. So at this point, all I need to do is multiply across the top, divide by the bottom, and I get my answer. And when I do that, I get 42.5 minutes. So 42.5 minutes. That's the amount of time it would take to filter all of her blood that's in her body. Now, sig figs. Again, the number of sig figs, when you're multiplying and dividing, the number of sig figs in your answer should be equal to the least number of sig figs in your measurements. So we have 4 sig figs here. This is exact, so we're going to ignore this. We have 4 sig figs here. We have, this is exact, so ignore that. And we have 3 sig figs here. So 3 is the least number, so we should have 3 sig figs. 1, 2, and 3. So we got our answer in the correct form. Next, we have problem number 3. The average heartbeat is 75 beats per minute. Oh, that's going to be a conversion factor. 75 beats per 1 minute. So that's a possible conversion factor. Next, we need to figure out where we're going to begin and where we end. The beginning of the problem is the end of the beginning of the question, is the end of the problem. The beginning of the question is how many times? So we're looking for a number of times of beating, right? So number of times that the heart beats in what? A week. So the week is where we're going to begin. So we're going to start with 1 week. So we're going to put 1 week on the top over 1. And we want to convert that to the number of heartbeats. So we got to get to minutes, right? So if we could convert time from weeks to minutes, we could then use minutes and the 75 beats per minute as a conversion factor to convert to heartbeats. So I know that 1 week is 7 days. So I'm going to put 1 week on the bottom, 7 days on top. Weeks cancel out. I know that there are 24 hours in a day. So I'm going to put 1 day on the bottom, 24 hours on top. So days cancel out. Next, I know that 1 hour is equal to 60 minutes. So I'm going to put 1 hour on the bottom, 60 minutes on top. So hours cancel out. I have minutes. Now all I need to do is use my conversion factor, 75 beats per minute. So I'm going to put minutes on the bottom. So 1 minute on the bottom and 75 beats on top. That's heartbeats. How many times does the average person's heart beat? We've got the right thing on top. So we got heartbeats on top. We are done. Oh, we forgot to cancel out minutes. So now all I need to do is multiply across top, divide by the bottom, and I get my answer. And when I do that, I get 7.6 times 10 to the fifth power beats. So that's the number of beats in a week. That's a lot of heartbeats. So now for sig figs. Again, since we're multiplying and dividing, we have to follow the rule. And the rule is that your answer should have the same number of sig figs as the least number of sig figs in your measurements. And we're going to ignore the exact conversions. So 1 week and 7 days, that's exact. 1 day, 24 hours, that's exact. 1 hour, 16 minutes, that's exact. This is the only one that's not exact. So 75, that's 2 sig figs. So our answer should have 2 sig figs, and it does, 7 and 6. So this is the right answer. Last but not least, we have 1 molecule of the enzyme amylase, and we're told that that can convert 1.0 times 10 to the fifth molecules per minute. Ooh, that's a conversion factor. So we can use the 1.0 times 10 to the fifth molecules per minute. That's a possible conversion factor we can use. And that's molecules of starch into the sugar maltose, right? So this is going to be useful. Now, that's the only conversion factor I can see. Now for the question, we got to figure out where to begin and where to end. The question will tell us. So the beginning of the question is the end of our problem. How many days? So we need to find the number of days. Well, where are we going to start? Let's keep reading. How many days would it take one enzyme to convert 1.0 times 10 to the 9 molecules of starch? So this molecules of starch is not related to anything. It's a standalone information. That's a dead giveaway that we're going to begin with this. This is a billion molecules of starch. So we're going to start with a billion molecules. So we're going to write down 1.0 times 10 to the 9 molecules. And I'm going to put ST for starch over 1. Now I need to convert molecules of starch to something. Here I know that 1.0 times 10 to the 5 molecules of starch is converted every minute by this enzyme. So I'm going to use that. So I'm going to put the 1.0 times 10 to the 5th molecules on the bottom, and that's going to be per 1 minute. So molecules cancel out. And then again, this is molecules of starch, ST for starch. Now I have minutes. What do we want? We want how many days? So I need to convert minutes to days. So I know that 1 hour is equal to 60 minutes. So I'm going to put 60 minutes on the bottom and 1 hour on top. So minutes cancel out. And I know there's 24 hours in a day. So I'm going to use that, convert to days. So 24 hours on the bottom and 1 day on top. So hours cancels out. I have days. They're looking for days. How many days? So we're done. So all I need to do is multiply across the top, divide by everything on the bottom to get my answer. And when I do that, I get 6.9 days. So that's going to be equal to 6.9 days. So it's going to take this enzyme 6.9 days to convert a billion molecules of starch into maltose. Okay, so sig figs. Can't forget sig figs. So remember, because we're multiplying and dividing, the rule is that your answer should have the same number of sig figs as the least number of sig figs in your measurements. So here we have 1.0, that's 2 sig figs. Here we have 1.0, that's 2 sig figs. This is exact, 1 hour, 60 minutes, exact. 1 day, 24 hours, that's exact, so we ignore that. So the least number is 2 sig figs, so our answer should have 2 sig figs, 6, 9. It does, we're done, that's it, hallelujah. I hope this was helpful. If you enjoyed this video, if this was useful or entertaining or helpful in any way, then please like the video, share the video, hit that like button over somewhere down here. Also, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a particular problem you need help with, or if you have a topic you want me to cover, put that down below. I would love to do that for you. Thanks for joining me, and have a great day.